so that those who haven't go to this class will suffer a little. So select all the data, right? And then go to the data type and then pivot table, create a pivot table. And then there will be a pivot table builder. Your first step is to jack the survival into the columns. And then drag the smoking into the row labels. Once again, drag the smoking into the values. Now, you get your first pivot table, contingency table. For example, there are 166 of the non-smoker die, and 125 smoker die. But it is still difficult to tell whether smoking associated with the death rate or not. So we want to calculate the death rate as well. So drag the smoking again into the values. And then there is a little I here. And correct that. By default, the summary statistics is cam, so you don't need to change that. But there's option here. You can choose show data as what, and then there are many options. In our case, we can choose percentage of row. And then the results should be like this. Okay, what you can find from this table. What? Non-smoker die more, yeah. So if you are a journalist, will you write a story and saying that smoking is actually good for your health? Based on this data. Okay. If you only have this data, maybe you can say that. Okay, any problem creating this pivot table? So in our first analysis, we will find that non-smoker actually die more. But actually, we have a third variables here, which is called the age group. It is actually the initial age of that particular volunteer. Okay, meaning that his or her age in the time 0 at the beginning of the study. we can break down this pivot table by age group. And then we may have a better insight on what is actually happening. And we can drag the age group into the row. And you should have something like this. Now we stratify the death rate by age group. And then we can compare the death rate for each age group. And then what can you find from this analysis? Come on, you need to write a story about it in the assignment. So you need to know how to describe the findings from this table. Okay. Do you want to try? Anyone want to try? If no one, then I will try to explain it. Yeah.
So, based on their initial age, past 20 years, they mostly die.
Yeah. 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 And what else? Okay, what is your opinion about the death rate and smoking by looking at this table? Okay. You can compare these numbers from each age group. Okay. For example, in the young age group, the youngest age group, among the smoker, the death rate is 2 times of this one, right? This group is actually my age group. The death rate is very similar. Yeah, I'm almost falling into this age group. And for this one, okay, again 2 times, about 2 times, right? 5, 7, and 10 something. This one 15, and then 20, 1 point something. This one again 1 point something. This age group, more or less the same, but still higher. Wait. And as you can see, smoking actually affecting all of us this age group, right? Among the smokers, only this one is lower. But this age group is the largest group in the entire data set, meaning the number of subjects from this group is very high, so that their results obscure the entire group results. This is a classic example of Simpson's paradox. And you can Google about it, what is Simpson's paradox. And there is one more explanation for the reason why the 25 to 34 age group in the non-smoker groups have a much higher death rate. Okay, in this age group, the death rate is actually very low. Okay, you will not expect the people in this age group like me suddenly die. Okay, and they will only die from very emergent disease or accident, right? And after 20 years, like 25, and then they become 45, and this one becomes 54. They are still very young, right? So they're healthy, right? This difference is only less than 1%. So we can consider this as a random variation. But for this group, when they get old, they are more likely to get chronic disease like cancer, heart attack, diabetes, things like that. And those chronic diseases are actually associated with smoking. When they smoke, they are more likely to have cancers. So that this group have a much higher death rate among smokers. And for the oldest group, they will die. They will die anyway. So whether they smoke or not, the difference is not that big. So yeah, this is the explanation for the results. Remember, stronger claims require stronger evidence. So, and stronger evidence meaning that, for example, whether dead claims still hold true in all the age groups. Any problem with this part? Okay, now you know how to do the task 2 of the assignment. Actually, this week assignment is a little bit easier, but you need to research a little bit by yourself. And okay, so we will move on to task 1. Okay, we start from task 2 and then task 1. For task 1, we need to create some data. And if I have promised you, we need to conduct an experiment. Okay, and for the apparatus of the experiment, we have cups. I can promise you these cups actually. I buy it from this morning. Eye patches. I don't know whether it is clean or not. And then, let's move to this part. And then we have stacks of cards. And we have selected 15 cards from here. And most of them, they're roughly equal size. Right? And this one we have 8. The red one we have 8, and the black one we have 7. Okay, we will use it as well later. But we still miss the most important element, most important apparatus of this experiment, and I will take it downstairs right now. So give me 1 minute.
上次嗰把聲都入咗去，我想坐啲啊！
做咩女神？
做咩女神？女神唔可以咁樣㗎。
你錄埋入去呢？
唔緊要，我唔係女神咯。
聽下歌啊，我哋。
好啊，你播。
你播嘅。
冇名嘅喎。
Big Bang。
Big Bang 唱乜嘢先得㗎？Big
喂
Bang。
，OK，我後面有韓國人。
係啊。Big Bang 唱咩歌先得㗎？
佢哋應該識唱。
好難聽。
你真係喺度。
黐線啦！
好大聲。
好濃。佢翻咗嚟。
Okay. We have Pepsi and Coca-Cola here. And okay, if someone claims that you can predict the future, you need to create an experiment to verify it. Okay. For example, those fortune tellers during the Lunar New Year's, they make a lot of predictions about the future. You can verify those predictions based on an experiment. And in order to conduct a good experiment, we need to have a good research design. And we will learn a little bit about how to create a good experiment from this exercise. And also, we need a volunteer. Okay, anyone who can think that, or anyone who think that you can tell the difference between the taste of Pepsi and Coca-Cola.
我唔識喎。飲可樂嘅。
Any volunteer? If there is no volunteer, then I will randomly pick somebody.
我不祥嘅預感。
Come on, it's fun. Yeah,
係咪好新鮮
yeah,
我
just
問你佢。
有冇人過意嘅？
我以
我
為。
我要。
Okay, what's your name? Michelle. Okay, welcome with Michelle. We will conduct an experiment on you. And I need two more. Okay,
Volunteer.
two more volunteers.
Boys.
I mean, okay, another volunteer is not doing the tasting part, so it's for doing the other mechanics of the experiment.
冇問題。
Okay, I need one volunteer to record the results of the experiment. Anyone? It's easy. What? Okay,
咩啊？
you can
溝
do
女
one.
仔嘅。
And then I need one more volunteer.
你冇嘢嘛？
I need one more volunteer to do the allocation of shipment. How about
呢
you?
個好似玩啲。
You. Okay. Allocation. Do the allocation. Okay, I will tell you what is allocation. And then because you are here, you will be the one to do the randomization. Okay. And okay, the mechanics of this experiment is like this. Okay. Would you please shuffle these cards? Okay. And then you open one card.
冇人講嘢都係釘住。
Okay. This card is red, right? So if this card is red, then the allocator, meaning you, put some Coca-Cola into the cups, and then let Michelle taste it. Oh, let Michelle taste it, and then Michelle will have 10 seconds to tell whether it is Coca-Cola or Pepsi. And then you, what you need to do is to record the allocation and also the answer.
OK，
And C or P, C meaning Coca-Cola, P meaning Pepsi.
我全部我哋做呢個好簡單。
Okay. All of you know the flow of the experiment now, right? Okay. But the most important element is that you need to blindfold it.
開發魚仔兩身，唔知好細個。
Okay, can you make sure that she cannot see anything?
呢個幾多手指啊？
十啫。
睇到喎。
And okay, let's get started. Okay, you need to open it in a sequence. Okay, when you shuffle it, just open one. Don't shuffle every time. Okay. Okay, you shuffle it again. Okay, red card means Coca-Cola because red is Coca-Cola. Right? And don't give her any hints.
因為見唔到個樣之後覺得
Just a
唔靚
little. And give it to her.
好熱啊，小心。
唔係人入到我哋。
佢
點咗
攤出嚟就要噴落你身上。
1、3、1、2、3，咩嚟㗎？
Okay, next one.
哎呀，我噴落嘴角添，唔緊要。噴落去。OK。
你講下你嘅 Angel 先有啲聽眾。係咁先嘅。
講多餘嘅説話係咪？
櫻桃食早餐先。
一樣味嘅 Coca-Cola。Coca-Cola 呢個我肯定。
係啊。
買咗幾多罐嘅？
頭先剩翻嘅。
買全部都係
真係好委屈，呢個講得好委屈。
Is the leftover from the previous tutorial. And and no one want to have get the cola after the experiment, so I need to take this.
我开始放唔出 Coca-Cola 同 Pepsi 啦，呢啲。Coca-Cola 啩？飲完未啊？
未嘅，到呢度啦。
飽啦。因為明顯飲得冇味覺咯。
喂，點解嚟到同學你啱啱真係對咗正面講先？
真係㗎，我眯埋咗眼。
有冇錯對住阿 Fin 啊？你都對住阿 Fin。
好似飲水。
我咪話你。
唔係因為我分唔到。
而家喺度太冇上堂，我哋走步冇任何。大家係咪好疑惑而家做緊啲咩咧？同埋錄緊音㗎。
係啊。
entertain 下你哋啦，
好飽啊！
我哋實飲可樂，你哋睇唔到。
得啦。
我知啊，唔好講呢啲。今日你哋
真啊！
佢係咪除得眼罩？
係啊。
得㗎。
係啦。
我哋
你整啦。You do it. Okay. And would you please show the entire class the raw data of this experiment?
冇啊！佢真係少。好似八四嘅。
我而家都好甜。
So if anyone like those cola, please take it.
OK 㗎。
Take it. Take it as a trophy.
其實你咪見到 Kelvin
係咯
BB，所以你就揀咗 Kelvin。
唔知
你 BB 咯。
And we can enter the data into 3 columns, which is the cups,
暈咗。
and results and the gas.
邊個嚟講？
褪咗一個位，全部都褪咗一個位。
Okay, so now please enter those data and we will do the analysis together to see whether Michelle can tell the difference between Coca-Cola and Pepsi. And okay, and then I will tell you what is the essential element of the experiment. When I was in college, I do the same. Our professor do the same experiment on us. but the difference, the material that we need to taste is not Coca-Cola or Pepsi. It's much more difficult. It's whether the milk tea is milk first or tea first, or the tea first or milk first, and things like that. Okay, after you enter the data should look like this. And again, we need to create a pivot table, contingency table. But this time, thing is a little bit different. The columns, the gas, so C or P. And this one is the actual or the randomly allocated one. C or P. Okay, let's consider the case of Coca-Cola as positive case, and Pepsi as the negative case. And we will create a contingency table like this. And for these two numbers here, we have the technical terms. A is called a true positive, and D is the true negative. And this one is the, actually we also have term, this one is called the false positive and false negative. You should have know this term from the story about like diagnostic tests. For example, whether the breast cancer can be detected by certain kind of tests. You have terms like true positive, false negative, and things like that. So, in this experiment, if Michelle can tell the difference between Coca-Cola and Pepsi, the true positive and the true negative should be very high. Agreed, right? And also, if you calculate the proportion, these two proportions should be very high. Also agreed, right? So if this proportion is 50-50, actually meaning that Michelle cannot tell the difference. Okay. And we need to do this analysis. But before that, I want to tell you what we have done in the experiment, right? If you can see, Michelle has been blindfolded during the entire experiment, right? This is important for this experiment because if Michelle can see what's your name? Athena, give to her, then Michelle can just tell what it is, right? So the first thing, blindfolded is really important. The second one is the randomization, meaning that young lady, what's your name? Huh? Samantha, okay. He's doing the randomization. For example, if we have a predictable sequence of allocation, like the first 5 is Pepsi, and then another 5 is Coca-Cola, and then a predictable sequence, Michelle may be able to guess what is the next one. Okay? Makes sense, right? These are the most important elements of the experiment. Okay? Remember that, because you need to do it. You need to write about it in the assignment. Okay, and then we will do the analysis with data. And it is actually the same. Select all the data, I mean only these two columns, and then insert a pivot table. And put the random into the row. Put the random into the row, and the guess into the column. And again, the random into the values. By default, this is a count. And jet it once again, and then select the row percentage. You are doing good.
Thank you.
Not that bad. Yeah, from my explanation, each two shell should have very high number if Michelle can tell the difference, right? Actually, Michelle can tell the difference. Somehow tell the taste of Coca-Cola, because this number is quite high. But not so good at telling the difference between Pepsi. And it also reflected in the numbers. For example, 75% of the Coca-Cola has been tasted correctly by Michelle, but only 42% of the Pepsi allocated has been guessed correctly by Michelle. So, from the experiment, we know that actually it is very difficult to tell the difference between Coca-Cola and Pepsi for non-professional players. Okay, we have some professional people who can do the same test, but who can have an accuracy rate of 90% for both of this, and they are professional. They have a very good tongue, but we are not. Okay. Any problem creating this pivot contingency table or the interpretation? Put the guess here and then the random. No, random here and guess here. Sorry about that. Have you inserted space after the T? You go back to the data. Maybe you have inserted a space after something. After you clean that up, you issue it. Yeah. Right? No. Yeah. there are still two data. I think I could attend the data once again. You are not so concentrated right now when you're doing the data. Okay. And one final information. The assignment actually asks you to do a research online, or if you like old school, you can go to library to study what is the difference between a population and a sample. Okay, and then it will ask you whether this experiment we are collecting a sample data or population data. Okay, then I can use this experiment as an example to explain what is the difference between the population and the sample. If what we are collecting is the population data on the taste tests, then I need to buy all the Coca-Cola and all the Pepsi in the entire universe, and then let Michelle taste it, all of them, and then we get the data like this, and then do the analysis. This one is the population data. Okay. But for the sample data, we just analyze a very small subset of the entire population, meaning all the Pepsi or all the Coca-Cola in the entire universe. And then from that small sample, we make prediction about the population. Okay. Population actually meaning all the things, right? Sample is a small subset of the population. And in the future tutorial, I will tell you how to select a representative sample from the entire population so that you can make an accurate prediction about the population from the sample. Okay. So if you have no more questions, you can go now. And I will upload this data onto the GitHub. So if you haven't entered it, or if you have,
寫 Michelle 如果我同上一組
我已經 save 咗上一組啦。I've already saved the data from the previous group. This one is from William. So his
好似
result.
好似嘔完咁樣樣出嚟啦，啱先我哋上面見到係咩人喺後面出嚟，可能佢
即係我全部變咗 percent。
Oh,
因為有啲錯。
some of them you need to display it as a count, some of them you need to display it as a probability. Okay, just click I here. Okay, 顯示資料為你將其中一個揀翻做一般，有啲確定係咁。
哦，thank you。
Anyone like Pepsi? Good choice.
唔係，我已經見下先。9係 C，9呢個係。